Okay, so first of all, we obtained the arc length formula, right? So we have a parameterized curve given by x equals to x of t, y equals to y sub t, t between a and b. The length of the curve is then given by this formula here. It's the integral from a to b of the root of dx dt squared plus dy dt squared dt. So basically you take the derivatives of the component functions of the curve with respect to the parameter t, you square them, you add them, and you take square root, and then you integrate it from a to b. So the first thing I want to do is go over an example that I didn't complete last time. So suppose I have the curve C given by x equals to e to the t plus e to the minus t, y is given by 5 minus 2t, and t varies from 0 to 3. What's the length of the curve C? Last time we set up the integral for that, right? So basically the length will be given by integral from 0 to 3, and you take the derivative of x with respect to t. What is that? It's e to the t minus e to the minus t, right? So you square that. So take the derivative of x, which is e to the t minus e to the minus t, square that, and then take the derivative of y, which is negative 2, square negative 2, and then you take this sum of the two, and then take the square root. And that's the integral formula for the length. Now we have to compute that integral. Is everybody okay? We set that up last time. So today I just want to compute this for you. In order to compute this integral, the goal I have in my mind is that I want to sort of write the quantity inside the root, the quantity inside the root. I want to write it as a perfect square. If I can accomplish that, then I can get rid of the root, and hopefully then I can compute the integral. So how would I write the quantity inside the square root as a perfect square? Well, let's look at the quantity inside the square root separately. The quantity inside the square root is e to the t minus e to the minus t squared plus negative 2 squared. So what is that? I am going to expand the square. Basically, what I have is e to the t minus e to the minus t times e to the t minus e to the minus t, right? So you can use FOIL, or you can use the binomial theorem to expand the square. So let's use FOIL here, and then what's the square of negative 2? That's 4. When you multiply out here by using FOIL, then what do you get? You get e to the 2t, you get plus e to the minus 2t, and then when you multiply e to the t and e to the negative t, you're going to get 1 and 1, right? So that's going to give you negative 2. So when you expand the square, that is, you multiply out, you get e to the 2t minus 2 plus e to the negative 2t, and the 4 is from negative 2 squared. So finally, negative 2 and 4, when you add them up, you get e to the 2t plus 2 plus e to the negative 2t. Is everybody okay with this so far, with the algebra? Now I want to rewrite this as a perfect square. Now, if you know the binomial theorem, you can do the problem in this way. I'm going to do it two different ways. First of all, I'm going to think of this as e to the t squared, and the last one I'm going to think of as e to the minus t squared, and the middle term 2, I am going to think of that as e to the 2 times e to the e to the t and e to the negative t. So that's how I'm going to think of this expression. I haven't changed anything. All I did is rewrote that expression. Notice that if I think of e to the t as a, I'm going to think of e to the t as a. So I have a squared plus 2a, and I'm going to think of e to the negative t as b, and then I'm going to think of e to the negative t as b, so I get this. So what is a squared plus 2ab plus b squared? A plus b squared, right? Which is then going to give you what? Which is then going to give you e to the t plus e to the minus t whole squared, right? So I can rewrite that expression as a perfect square. Is that making sense? So this is how, if you want to use the binomial theorem, some of you may not like it, but I'm going to redo it in a little bit differently. Did that make sense? Okay, so let me erase what I have because I want to redo that, okay? You guys are done writing it down? So this is one way of doing this problem. That is writing it as a perfect square. The other way that I would do it is, okay, so from this point I am going to factor out e to the negative 2t. So the negative exponent that I have, that's what I'm factoring out, e to the negative 2t. What am I going to get? I'm going to get three terms. I am going to get three terms inside the parentheses. What are the terms? Well, each term will be divided by what you are factoring out, right? So the first term inside the parentheses would be what? The first term inside the parentheses would be e to the 2t divided by e to the negative 2t, right? The second term would be 2 over e to the negative 2t. The third one would be e to the negative 2t divided by e to the negative 2t, right? So when you factor out e to the negative 2t, that's what's happened. And now you can easily see what that is. This is e to the negative 2t. And what is happening here? You're getting e to the what? 4t, right? You're getting 2 e to the what? 2t. And you're getting 1. Are we okay with that? Now, finally, I am going to do the following. I have e to the negative 2t. Here, I'm going to think of this as e to the 2t squared. And I have 2 times e to the 2t again, plus 1. Now, I am going to think of e to the 2t as let's say, we didn't use x here at all, did we? No, we did use x. Let me use something else. What can I use? Let's say, I better plug in the power. What letter would you want to use? Let's use, I don't know, B or something. Yes. So let's use S here. My point is, I just wanted to show you what this is. So this is here. Let me use red to show you what that is. So if I think of e to the 2t as S, so I'm going to get S squared plus 2 times S plus 1, right? If I think of e to the 2t as S, that's what I'm getting. So what is S squared plus 2S plus 1? Can you factor that out? S squared plus 2S plus 1? Can you factor that out? What is that? S plus 1 times S plus 1, which is what? S plus 1 squared, right? So what am I getting then? What I'm getting then is this is e to the negative 2t. And inside the brackets, what I have is e to the negative, sorry, not negative, e to the 2t plus 1 squared, right? Everybody agrees? Remember, S was e to the 2t. So I have done what I wanted to do. I have this. Let me just not use the brackets because we don't really need that. So let me erase that. Let me erase the brackets here. We don't need that. Okay, so let's now summarize what we did. We said we started with the quantity inside the root, right? We started with the quantity inside the root of the integrand, and we said that quantity is the same as what? This quantity here. So what is the length of C then? The length of C then would be the integral. What are the limits for, was it 0 to 3? 0 to 3, and I have the root. Now inside the root now, what am I going to write? I am going to write e to the negative 2t times e to the 2t plus 1 squared dt. Is everybody okay with that? And so you can now take the root. Can someone tell me what's the root of e to the negative 2t? What's the root of e to the negative 2t? Well, you're going to divide the exponent by what? 2. So you're going to get e to the negative t. And the other one is just going to be e to the 2t plus 1. So I get rid of the square root. Now, what is that equal to? Multiply out, you get e to the t plus e to the negative t when you multiply out. And now I can easily take the integral. What's the integral of e to the t? It is itself. What's the integral of e to the negative t? That is negative e to the negative t. And then I have to evaluate between 3 and 0. Plug in 3, you get e to the 3 minus e to the minus 3. When I plug in 3, that's what's going to happen. When I plug in 0, what am I getting? E to the 0 minus e to the 0, right? So what's the end result? E to the 3 minus 1 over e to the 3. So that's the length. That's the length of the curve. Any questions, anybody? Any questions? I'm going to do one more problem, but this problem I'm actually not going to show you the steps. I'm just going to tell you overall what to do. But in my YouTube channel, I have posted a lecture number 36, which is a fake lecture number because it's not really a lecture that I gave in the class. But that lecture has more examples of computing lengths. So if you want to see more examples of computing lengths, you can watch that video. Okay. Okay, so let's look at the second problem that I want to do. If you have, so we actually looked at this problem last time as well. We just didn't do this. If you have the graph of a real valued function f of x, what's the length of that curve if x is going from a to b? Well, we said that the length of a curve like this is given by integral from a to b of the root of 1 plus f prime of x squared dx, which is the same as integral from a to b of the root of 1 plus dy dx squared dx. So now, if I go back to my problem here, I have the function y equals to f of x, and f of x is 1/6 x cubed plus half x to the negative 1. X is between 1 and 3. What's the length of the graph of this function between 1 and 3? Well, the answer is you take the integral from 1 to 3 of what function? It's the root of 1 plus. So what goes next? You take the derivative of the function dy dx. What is dy dx here? Well, the derivative of x cubed is what? 3x squared. So you get 1/6 3x squared, which is be what? Half x squared. And then what's the derivative of x to the negative 1? That will be negative x to the negative 2. So you get negative half x to the negative 2. So if I plug that in, what I get is integral from 1 to 3 of the root of 1 plus half of x squared minus half of x to the negative 2 whole squared dx, right? And now I have to compute that integral. In order to compute this integral, again, you have to write the quantity inside the root as a perfect square. How would you do it? Well, you have to expand the square, multiply out everything, and if you do that, you're going to get 1/4 x to the 4 half plus 1/4 x to the negative 4. Now you're going to factor out x to the negative 4 and 1/4. So if you factor out 1/4 x to the negative 4, you're going to get x to the 8 plus 2x to the 4 plus 1. And then I'm going to think of x to the 8 as x to the 4 squared plus 2 times x to the 4 plus 1. And then x to the 4, think of that as y. So it will be y squared plus 2y plus 1, which would be y plus 1 squared again. And then you can write that as x to the 4 plus 1 whole squared. So once you have accomplished this, writing the quantity inside the root as a perfect square, now we're going to put that in the square root. If you put it in the square root, you can cancel out the root. You get something like half of x to the negative 2 x to the 4 plus 1. Multiply it out. You get half x squared plus half x to the negative 2 dx. You're integrating from 1 to 2. I'm pretty sure you know what to do after that. Okay, very, very quickly. But this problem is done in the video number 36 if you want to look at more details. Okay, but I won't go over more than this because I want to get to the homework problems that you have to finish today. So here's I'm ending. If you have any questions.